Hi class, Miss Womack here. Just wanted to shoot a quick video to kind of go over the instructions for Law of Sines. And what we talked about in class is that we find that in all triangles, not just right triangles, that there is a proportionate relationship between the opposite side and its opposite angle. That is this side right here, which is A, that side, the blue one, has a proportionate, and if you set a proportion over the sine of this angle here, if we had the measure, then it would in fact be proportionate to the side that's over here and over the sine of B, which is over here. So if we have an opposite relationship, we can actually use the law of sines to solve for any kind of triangle whatsoever. So let's look at a couple of examples that we talked about in class. And in this case, we do see an opposite relationship between the 120 degrees and the 40. Do you see right here? These are actually opposite of one another right there. And so we can set up law of sines to find any number of information. We could find all the information, like x, or we could find y over here. And we also talked about the sum of the interior angles adding up to be 180. So you could subtract and even solve for z right over here. So let's play with this a little bit. It's just another tool to put into your trig or geometry toolbox. So how would we set them up? We would take the 40, which is our side, over the sine of 102 degrees, and we're going to set that equal to whatever it is that we want to solve. Now again, you must have an opposite relationship like we did with the blue arrow. So let's see. We can now solve for y. Do you see this 25-degree angle is opposite of the y? It's way over there, our opposite side. So we could, in fact, solve for that one. So we'll put y over the angle, which is, or the sine of 25 degrees. Now we went back over cross multiplication, so all you need to do at this point is you're going to cross multiply 40 times the sine of 25. So in your calculator you put 40 times, and I've been putting a little star there because that does show up in the TI-84, the sine of 25 degrees. Now automatically the TI-84 will start with a parenthesis like that. You have got to make sure that you close the parenthesis after you put that in there. And the last thing we'll do is divide by the sine of 102, and we will find our answer. Now remember, if you get something strange, don't forget those parentheses right here and here. If you get something strange, you may be in radian mode, just like we talked about in the previous video. So I'll give you just a moment to plug that into your calculator to find an answer. So our answer is 17.28, and we'll round to 17.3 units. Units are not described in this particular triangle, but we're always on the lookout for them. Now we could also continue solving for any other opposite relationships that we see here as well. But I do want to talk to you about the rule that we talked about that you may have studied previously, that the sum of the interior angles of a triangle, that is the 102, the 25, and the z over here, actually add up to be 180 degrees. So with a quick subtraction problem, doing 180 degrees, subtracting 102, and also subtracting 25, we can find our, let's do that real quick, 180 minus 102 minus 25 actually give us a 53-degree angle. So we know that Z is equal to 53 degrees. And we can now set up another one to find the length of X if we want to on this particular triangle. So I'll let you do that as a challenge problem. In the meantime, let's look at another one. All right, again, there must be an angle and its opposite side before we can use the law of sines. I see that the side that has a 10 on it has an opposite angle of 50, so thumbs up on this one. We can solve for X. So we will need to, once again, so we'll set that up. We'll put 10 over the sine of 50 degrees is equal to, and we do have the X, and you don't see the angle opposite of it, so you do have to, once again, use the sum of the interior angles of a triangle are 180 degrees. So we'll take 180 and subtract 50 and subtract 41 more, and we end up with 89 degrees. So this little angle over here we just solved for was 89 degrees. Now these aren't drawn to scale. And we can now set up our, because we have another opposite relationship, we will put X over 80, sine of 89 degrees. Sine of 89 degrees. And now cross multiply. So we'll take the 10, multiply that by the sine of 89. Don't forget those parentheses when you're entering that into your calculator. And then divide that by sine 50 to find our answer. Don't forget the parentheses. Alright. So our side X is going to be equal to 13.05, which will round to 13. Now we had one other example that we want to go over, and that's what do we do when the dishwasher takes over the video? No. What do we do when we have theta, or we're looking for an angle? So we're going to set it up very similarly. We do know that we can do the law of sines because we have this opposite relationship. The 13 and the 105 are opposite one another. So we'll write 13 over the sine of 105 degrees will be equal to, and we do have the 11, and we'll put sine theta on the bottom. 11 over sine theta. Now we'll go ahead and cross multiply like we normally had done before, but we're going to do something different when we plug it into the calculator. Whenever we look for an angle, this will happen. We'll actually push the shift key, it's blue, on the TI-84, and it will look like more like this, the sine of -1, which means we're getting ready to put an angle in. And then it'll look like all of the other ones, all of the other problems we talked about. 11 times the sine of 105, and don't forget the parentheses in your calculator, divided by 13. Just make sure that you have this -1 showing up on your calculator, and you will get the correct answer, which in this case is 54.8, and we're finding an angle, so that is degree, 54.8 degrees. Hope this video was helpful.